Hello students, in this video we are going to look at another application of integer linear programming. In my previous video we saw the application of capital budgeting. This video will show you the application for distribution system design. So let me take you to the distribution system design. It is again in the chapter 7 and you will see here under 7.3 application of 0-1 variables distribution system design. Okay, now in distribution system design uh, you will also find my another video which is transportation and transshipment type. So there we try to minimize the total overall transportation cost. Now distribution system design is one step further. Here it is a sort of a transportation model, but along with there is a decision for a new facility. Okay, so basically it is a mix of the two, that is transportation and capital budgeting sort of. But so we'll start with this distribution system design. The Martin Bake Company operates a plant in St. Louis with an annual capacity of 30,000 units. So they already have a plant in St. Louis, right? Product is shipped to regional distribution centers located in Boston, Atlanta, and Houston. Because of an anticipated increase in demand, Martin Bake plans to increase the capacity by constructing a new plant in one or more of the following cities: Detroit, Toledo, Denver, Kansas. The estimated annual fixed costs and annual capacity for the four proposed plants are as follows. So proposed plants: Detroit, Toledo, Denver, Kansas. This is the annual fixed cost, one time cost, and this is going to be the annual capacity. The company's long-range planning group developed forecast of an anticipated annual demand at distribution centers as follows. So Boston, Atlanta, and Houston will have 30,000, 20,000, and 20,000 annual demand. That is the forecast. So when you put this entire thing here, it will look like this. It will look like our transportation problem, where they already have this plant already in operation. This is already there, and the remaining ones are the ones which we are going to have a question mark whether we should go ahead for this Denver, Kansas, Detroit, Toledo, which one, right? And also these are the three distribution centers, and these are the demands which are in thousands of tons. So the arrows indicate the transportation routes, and these values on the arrows indicate the transportation per unit cost, right? So if you are sending one ton from Detroit to Boston, it will cost you $5, right? So this is what is a similar setup as that of transportation. The capacities are given for plants at Detroit 10, Toledo 20, Denver 30, Kansas 40, right? So here we are going to use our 0-1 variables for these four question mark plants. So Detroit D, T, D, and Kansas. So they have used Y1, Y2, Y3, Y4. Y1 is 1 if the plant is constructed in Detroit, 0 if not. Y2 is 1 for Toledo, 0 if not. Y3 1 for Denver and 0 if not. Y4 1 for Kansas City and 0 if not, right? And these values which are given, shipping costs, are already captured here, right? So basically in the exam you may be given these informations in tabular format. So first you need to declare your variables, and for better understanding, if it is you have time permits, you better draw these diagrams. This diagram clearly tells you a good understanding of the problem at hand, right? So now how to go about? We are going to assume Xij as the unit shift from ith plant to the jth distribution center. So Xij, where I will be from 1 to 5 and j will be 1 to 3. So my total transportation cost will be x11, 2 1, x2, x12, 3, x13, like that, right? So you will put all these values here. So you will get 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 terms here. You will see here 15 terms along with their per unit cost. So this is the entire total annual transportation cost, which you need to obviously keep in mind to minimize. But along with this transportation cost, we also have annual fixed cost, which is nothing but the cost here given, the annual fixed cost of proposed plans. Now, if y1 is 1, then this will come into action. If y1 is 0, this will not come into action. So we need to multiply them by y1, y2, y3. So that is what they have done here. 175 y1 plus 300 into y2 plus 375 y3 plus 500 y4. So this is going to be the annual fixed cost. Now, what are my constraints? The constraints definitely will come from both sides. One is the supply side and as well as the demand side. So here 10 is the capacity which I can't exceed. So I will have to write here, if you see here, x11 plus x12 plus x13 less than equal to 10y1. Why 10y1? Because if y1 is 0, then obviously all these three will be 0 only. We can't use the facility, because the model says that facility is to be dropped, right? So that is how you have to remember that this one has to be multiplied by y1, this one has to be multiplied by y2, and for St. Louis, because already the plant is there, we will have to just use 30, right? And so basically we will have these values here, and then for Detroit, Toledo, and for Boston, and then comes the demand side. So demand side, you will write Boston 30 equal to x11 plus x21 plus x31 plus x41, right? So if there is a confusion in your mind, better to watch transportation and transshipment videos before you come here, so that there will be clarity. So x11 plus x21 plus x31 plus x51 equal to 30 Boston demand. So in that manner we will keep everything here. So in this total cost, you have this transportation cost plus you have this one time fixed cost. So that will be the total cost you want to minimize. Then these are your capacity constraints here. That is your capacity constraints, 5 capacity constraints up to here, and then 3 demand constraints, right? So here it will be less than equal to, this will be equal to, and the most important aspect is this is your most important aspect, the variables. All the variables, because there are number of units transported on the routes, it has to be, cannot be negative, and hence it has to be greater than equal to 0. They can be 0, but they can't be negative. And also my y1, y2, y3, y4, which are my binary variables, and hence it will be 0 1. So this is your entire answer if you have asked to create the model. But before doing this, you need to do these two things. First, declare xij as your variables, and then declare y values here. They have declared this. So this will be your starting points. Declare your into the binary variables and declare your xij's, and then start writing your model. So this is how you develop the model, and then obviously we will have to take it to the Excel solver and solve it, which I have explained in my another videos, how to solve multivariable linear programming problems using Excel solver. So this is your distribution system design problem. Thank you.